Hello everyone, welcome to Math Freaks. So let's start today's session. So today we are going to do very exciting topics. So before that, let us practice the things that we learned in the previous lecture. So I would like to begin with a question from a rational root theorem that I taught you in the last lecture. So the question is something like that: if the equation, and this is the equation, x raised to the power 4 plus x cube minus 19x square minus 49x minus 30 is equals to 0, this equation has rational roots, then find the roots. Okay, so this equation has rational roots and you are asked to find the rational roots. Okay, so this question I also gave in the discussion group in the Telegram. You can join that too using our Google Classroom link. So try to solve this. Done. Now let's begin with my solution. So this is a very simple question. So it has been told that the roots are rational. So let us assume that the roots are in this form, p upon q, where again p and q belong to integer and their HCF is 1, correct? So in this form, so what was the theorem? That q will divide an and p will divide a naught, that is the constant of the polynomial. So if this is the case here, then p this q will divide this one. So q can be either, q has to be 1, correct? Now, so we find that this has become the integer root theorem, that is now the root is an integer. Okay, right? Because the integer root theorem was a corollary of the rational root theorem. So since q has become here 1, then p is obviously integer, so it has become integer root theorem. That's how they're related. Okay, now if p now here p will divide minus 30 according to our theorem. So the possible divisors of minus 30 is plus minus 1, plus minus 2, plus minus 3, plus minus 5, plus minus 6, and then plus minus 10, and then plus minus 15, and finally plus minus 30, correct? These are all the possible divisors of minus 30. Now what you have to do, now you have to check for if they are the roots of this equation. Now how will you check this? Using the remainder theorem that I taught you, right? So for an example, I'm showing you one example. Say I take minus 1, I want to check minus 1. So if this is the case, I told you that then we have to check for x plus 1 if it divides this one, right? So how to check? We have to take minus 1 and let's say this is p of x. Okay, p of x. So we have to find the value of p of x for x at minus 1. So if I replace x by minus 1, you can check that the answer is coming out to be 0. So we can say that minus 1 is a root. So what you have to do basically is use the rational root theorem and then find all the divisors and then check for all the divisors if this satisfies this equation, correct? Now how to check? You can use the concept that I taught you, that is value of a polynomial, how to find the value of a polynomial at different values of x. So now let me tell you the roots of this. Like if you check it, so the roots will come minus 1, minus 2, minus 3 and 5. These are the roots of the this equation. And also another thing that I want to relate is that, see, the number of roots here are 4, and as I told you in the previous lecture, that is the fundamental theorem of algebra, the number of roots of an polynomial or the number of zeros of a polynomial is equal to the degree of that polynomial. So here you can see that the degree is 4 and also we got the number of roots as 4. So this was another thing that we can relate to our previous lecture. So like this you can use the rational root theorem and the integer root theorem. Okay, now let us move on to next topic, that is the most interesting and most important topic, that is the Vieta'S relation. Okay, now in the basic maths I told you about the relation between the coefficients and roots of a quadratic equation. Let us try to recall that. In the basic math I told you that if ax square plus bx plus c is equals to 0, this is a quadratic equation, and let's say they have roots alpha and alpha 1 and alpha 2, correct? Now I showed you that, and these are very basics, right? You have also studied this in class 9th or 8th. So alpha 1 plus alpha 2, we all know, minus b upon a, and alpha 1 multiplied by alpha 2 is equals to c upon a. So this is something that we have known for a long time, correct? Now what Vieta did, he generalized it for a for n number of roots. He found out a relation between the roots and the coefficients of n degree polynomial, like generalized it. Now how did he do that? Very the derivation is very simple, I would say, if you understand. Now what Vieta did, so this is known as Vieta's relation. First of all, let us write the general equation of n degree. So an, again our this one, and I'm just skipping all these terms, and a naught is equals to 0. So this is a general equation, correct? Now say this equation has n roots because the degree is n, so this equation has n roots. For example, say the roots being alpha 1, alpha 2, alpha 3 and up to alpha n roots. Okay, now how can I write this? Can I equate this to x minus alpha 1 multiplied by x minus alpha 2 multiplied by x minus alpha 3 up to x minus alpha n? Can I equate this to yes, right? Now see, okay, if you did not get this, how I equated this, these are very basic. Like for example, if I say x square plus 3x plus 2 is equals to 0, so it has roots minus 1 and minus 2, right? So I can obviously write x square plus 3x plus 2 is equals to x plus 1 multiplied by x plus 2. Try this out sometime. Okay, so I hope that you understand. Now you have understood that why I can write this, why I can equate like this, right? Now very important, listen to it very carefully. The next step is very crucial. Now we equated this general equation to its factors, right? Now see, can I write, if I write only this much, is it correct? No, it is not correct. Why? Because we are missing the leading coefficient. Now you know, now I know, yeah, that you did not understand this. See, if you multiply the factors, I don't care about the other terms. I'm just interested in the x raised to the power n term. So here, from here you will directly get x raised to the power n. You will not, for, and here the leading coefficient is 1, but in our case the leading coefficient is an. So in order to get the leading coefficient, we cannot skip the leading coefficient, right? Because if we skip that, then this is not equals to this, then we cannot equate these two things. So we have to multiply the leading coefficient in order to get this one. So now we can equate these two things, right? Now once you equate this, now how do we solve a quadratic or an equation? We just compare the coefficients. We are going to do some brilliant questions today where we will be equating the coefficient. That's how we solve an equation. So here also, now listen very carefully. If I open the brackets, okay, if I open the brackets and if I compare the coefficient of x raised to the power n minus 1, now from here I can say that this will be an x raised to the power n. Very carefully see, this will be alpha 1 plus alpha 2 alpha 3 up to alpha n multiplied by x raised to the power n minus 1. See now how I have written this. See, this one, this whole term will be multiplied by this, then this term will also be multiplied by this one term, and like this will go on and go on. And if you take x raised to the power n minus 1 common, then this is what you are going to get. Correct. Now why minus? Because see, here is minus and there is plus, right? So minus will remain there. So, or how I can write this? Can I write this as sigma alpha I x raised to the power n minus 1? Similarly, if you move on a bit, what you will find is, then the next term, that is the coefficient of x raised to the power n minus 2 will come out to be alpha 1 alpha 2 plus alpha 2 alpha 3, like this. Like, or how I can write this as, this is sum of the roots taken 2 at a time, and now here will be plus. Why? Because see here you can see that this one multiplied by this one, so this minus and this minus gets positive, right? So like this you will get a positive sign, and hence this will be a plus. Now what you have to do, and you can go on, and okay, and at last there will be, now you have to equate the terms, like here, see. Now if you equate the terms, what you are going to get is, listen very carefully, for sigma alpha say taken 1 at a time, this will be a n minus 1 upon a n. Correct? This will be sigma n minus 1 upon a n. Now why? See this. From here we find that the coefficient of this one is a n minus 1, correct? But now here a n is extra, this a n is extra, so in order to remove it, we are dividing this with a n. Okay, so the sum of the roots taken 1 at a time will be a n minus 1 upon a n. And now if I this minus 1, there will be, wait a bit, this will be minus of a n minus 1 upon a n, and sigma alpha 1 alpha 2 taken 2 at a time will be a n minus 2 upon a n. Similarly, sigma of a alpha 1 alpha 2 alpha 3, that is summation of the roots taken 3 at a time, so this will be equals to minus of a n minus 3 upon a n. Now do you guys see a pattern? Yes, obviously. Now what is the pattern? See, if I take sum of the roots taken say p at a time, okay, sigma alpha 1 alpha 2 alpha 3 I have taken up to p, like p at a time. So what can I say is, this can be written as a n minus p upon an multiplied by minus 1 raised to the power p. Now you can check this for all the equations. This will come out to be true. This is Vieta'S relation, and for the product of the roots, this is always this one. There will be a minus 1 raised to the power n. Like this is the same as this one. Here we have just taken up to n. Here we were taking up to p, and here we have taken all the roots. So this is just same. Now this is what we call the Vieta'S relations. These are the relations between the roots and the coefficients of any any equation. Now I want to clear all your doubts, all your doubts. So one doubt may come, like the comparing part. For example, I'm telling you one thing. Let's take the x minus 1 coefficient. So in case of the x minus 1, like in the general equation, we had our leading coefficient as a n minus 1, and x raised to the power n minus 1 is equals to, now like what was it? Okay, this will be sigma of alpha I, say I from I to n, multiplied by x raised to the power n minus 1 multiplied by an. You should not forget about the leading coefficient, right? An multiplied by. So if we compare this, we directly get the relation that this gets cancelled out, and from here we get the sigma of alpha 1 is equals to an minus 1 upon an. Similarly, you can compare all the coefficients with and then you're going to find the same as I told you. Like the same process, you have to repeat this same process that I have shown you, comparing the coefficients, and you are going to get the relation. So remember this relation is very important, extremely important. Okay, now let's see that in the basic maths I told you like this relation. Now let's see if we can find out the same with Vieta'S this relations. So we took a quadratic equation, right? Ax square plus bx plus c. Now as we have written the relations in terms of an, so for this one example, to make you understand, I am writing this in the an terms. So this will be an x raised to the power n plus an minus 1, wait, yes, an x raised to the power n minus 1 plus a naught is equals to 0. Okay, so this has wait one thing, not like this, more simply. Say I write it as a2 x raised to the power 2 plus a ax a1 plus a naught is equals to 0. A2 is equals to a1 is equals to b, and a naught is equals to c. So now you tell me what will be alpha plus beta. This will be a n minus 1 upon a n minus 1 upon n, and now here n is 2, so this will be a2 minus 1 upon a2 minus 1 raised to the power 1. Sorry, one. wait. We have taken sum of roots taken one at a time, so this will be n minus 1, this will be n, then here will be 1, so this comes out to be a1 upon a2 multiplied by minus 1. Now a1 was our b, so minus of b, and a2 was our a, so from here we are getting that minus b upon a. For example, now if I take a cubic equation, correct, now you can do that by that is replacing ax cube, like a with a3, like that you can do that. So if I write the general cubic equation, so if I take one at a time, this will be minus b upon a. If I take two at a time, this will be c upon a. If I take now okay, correct, now if I take say 3 at a time, that is the product of the roots, this will be minus of d upon a, correct. Now how, again, like for this one I am showing you, so this will be product of the root, alpha 1 alpha 2 alpha 3 will be a of 3 minus 3 upon a3 multiply minus 1 upon 3, so this will be minus 1 upon a naught upon a3 if you take a, then and a naught as d, then minus d upon a. That's how we got here. Okay, so you can practice it for by quadratic equation, then all types of equation you can try it out, correct. Now I hope that you understood Vieta'S relation. For you I am explaining once again in a very crisp way. What we did, we have written the general equation of a general equation, this one, that is a n x raised to the power n. Then what we have expressed it or equated it to the as a product of its factor, and we have also multiplied the leading coefficient, because if we just wrote this part we were not getting the leading coefficient, so that's why we have to multiply it with a n. Then we expanded it, like expanded this multiplication, and from here we got to know that the coefficients of x raised to the power n minus 1, x raised to the power n minus 2, and all that. Then what we did is we just equated the coefficients of the expanded one to the original, that is the general equation, and we got the relationships, and these relations are known as Vieta'S relation that can be applied to any degree equation. Now if you understood it, now let us do some very interesting questions. This question came in, so this question came in AIME, that is the American Olympiad, in the year 1996. So the question is something like this: suppose you have an equation, suppose say the equation is x cube plus 3x square plus 4x, let me write it. Okay, the equation x cube plus 3x square plus 4x minus 11 is equals to 0. This equation has roots a, b and c. These are the roots of this one. Okay, and there is another equation that is we are having this x cube plus rx square plus 3x plus t. This equation has roots as a plus b, b plus a, and a plus c. Roots of this equation. Now you are asked to find t. I am telling you the question, I am repeating the question once again. Suppose that you have an equation x cube plus 3x square plus 4x minus 11 and it has roots a, b, c, and there is another equation x cube plus rx square plus 3x plus t whose roots are a plus b, b plus a, and a plus c. Now you are asked to find t. The question is simple. If you have understood the Vieta'S relation, then it will be very simple for you. Done. Now give it some good amount of time. It will take some time if you are doing this for the first time. Now let us begin with our solution. If I write the solution in the next page, okay. Now with the help of our Vieta'S relation, we can say that if a, b, and c were the roots of that equation, a plus b plus c is equals to a plus b plus c is equals to minus 3. Minus 3. Similarly, I am writing just all the relations of between the roots and the coefficients. Then we can write that ab plus bc plus ac is equals to 4, again with the help of Vieta'S relation, and the product of the roots will be 11. Okay, so if you have reached up to this part, also very good. Now you can also reach to this part with this particular section that I showed you, the relation between the roots and the coefficients of a cubic. So this was also a cubic equation, so that's how we can do this as well. Now let us move on. Now in the second equation we were asked to find t. Now you can directly find t with the relations. Now t will be nothing but minus of a plus b multiplied by b plus c multiplied by a plus c, correct? C. This was our equation. So we know that the product of the roots of a cubic polynomial is minus d upon s. So here d is t and a is 1, so minus this one is our answer of t, expression of t. Now what you have to do is, see, from here a plus b plus c is minus 3, or what we can say is, right, what we can say is t is equals to minus of multiplied by minus 3 minus a multiplied by minus 3 minus b multiplied by minus 3 minus c, correct? Now if you open this bracket, like if you multiply it, it will be a plus 3 multiplied by b plus 3 multiplied by c plus 3, correct? Now what you have to do, you have to just expand it. If you expand it, this will be abc plus 3 multiplied by ab plus bc plus ac and plus 9 a plus b plus c plus 27 is equals to t, correct? This is your final expression if you expand it. Now see, you have all the values of expression, like you have the value of abc, that is 11, ab plus bc plus AC, you have also this value that is 4, and this also has minus 3. So this one and then this one gets cancelled, and 4 multiplied by 3 is 12, and from here 3 12, and from here we get 11. So the final answer is 23. We are getting the value of TS 23. So this was the question. This is a very simple question that came in American Olympiad in 1996. So I hope that you understood the solution. Very simple. With the help of Vieta'S relation, first of all we wrote all the relations, and then from the first equation we derived the second equation, that is the roots of the second that is equation. So I hope that this one is clear. Now let us do another very interesting question. This is extremely interesting and extremely, now not hard but challenging question. Okay, so it is given that the product of any two roots of the equation, say x raised to the power 4 minus 18x cube plus kx square plus 200 x minus 1984. Okay, so the product of any two roots of the equation x raised to the power 4 minus 18x cube plus kx square plus 200x minus 1984 is minus 32. Correct. Now it is asked to find k. Try to done. Now this question I think came in USMO in 1984, as you can see the year. So I hope that you were able to find it. It is quite easy, not easy, even like moderate level. Now how to do this? Very simple. First of all, again, as we did in the previous question, you have to write all the relations that you know between the roots. So from this equation we can easily derive all the relations known to us, that is first of all being the sum of the roots taken one at a time. So see, if I take the roots to be ABC, D, A, B, C, D, right? So A plus B plus C plus D, this is equals to what? 18 minus B upon A. Now next will be sum of the roots taken two at a time, that is AB plus BC plus CD plus AC plus BD plus AD. Now this will be what? K, right? K. How? Again, Vieta'S relation. This is the solution now. Now the next what will be the next relation between the roots and the coefficient? That is taken three at a time, right? Up to this much I think everybody is okay. So ABC plus ABD plus ACD plus BCD, this will be what? Taken 3 at a time, right? So minus 200 minus 200, and the final, that is the product ABCD, is equals to minus of 1984, right? Now it has been told that the product of any two roots is minus 32. Now here is the very important part. From here the important part starts. I think up to here everybody of you is okay with this part. Now which two roots shall we take as their product being minus 32? The answer is any two roots. We will not care about which root we are taking and this also makes sense because we are asked to find the k, not the roots. So let's take any two root as the product of any two roots as -3. So let's say ab is minus 32, say, and you will see how this is not useful for us, that which two roots we are taking. You will see in a while. Now if I take AB as minus 32, then automatically our CD becomes minus 1984 divided by minus 32, that is equals to 62, correct? 62. Okay, now very interestingly, from here the more interesting part starts. So let's say we have two equations. Okay, say we have two equations, that is two equations, say the first equation being x square plus say mx and minus 32 is equals to 0, and its roots are say, a and b. We have to take a and b, right, because we have taken here minus 32. A and b are the roots. Okay, perfect. Now what is m? M is a constant whose value is a plus b, correct? M is a constant whose value is a plus b. Now say m is a constant. Okay, m is a constant. Similarly, x squared plus nx plus 62 is equals to 0. Here also we have taken another equation whose roots are c and d. Now see what we will do right now. Again we will compare the coefficients. How? If we multiply that to this two quadratic equation, then the roots of the quadratic equation will be a b c d, and a b c d is also a the roots of the original equation. So we can easily compare the original equation, and we can say that these two quadratic are the factors of the original equation. So we can say that x raised to the power 4 minus 18x cube plus kx square plus 200x minus 1984 is equals to x square plus mx minus 32 multiplied by x square plus nx plus 62. Now if you expand the factors, what you are going to the quadratic factors, what you are going to get is simple x raised to the power 4 plus m plus n multiplied by x cube plus 62 minus 32, that is the k, plus mn multiplied by x square plus 62n minus 32m x minus 1984. This is what you're going to get, right? Now what you have to do is you will compare the coefficients, like the x cube coefficient is m plus n. So, and in the original equation m plus n was minus 18, correct? Minus 18. And similarly 30 plus mn is equals to k, and 62n minus 32m is equals to 200, right? Okay, now if you solve this two equation, you are going to get a value of m and n. So let me write you that value, like you are going to get minus 14n minus 4, minus 14n minus 4. This is what you're going to get. So what will be your k then? M into n, you are going to get what? 56, and from here 30. So finally you get the value of k as 86. So all of you, those who have got the value of k as 86, You were correct. And for those who were not able to solve this, look at the solution. I hope that you were able to understand the complete solution. Okay, so with this question, our Vieta relations topic is over. I hope that you understood what is Vieta's relation. Let us move on to another important topic, that is Newton's sum. Very important and interesting topic, Newton's sum. Very interesting. Okay, now in this lecture I think I will only explain you this Newton's sum, and in the next lecture we will begin with some practice questions of Newton's sum. Okay, so what is Newton's sum basically? First of all, let us see an example. Ax square plus bx plus c is a quadratic equation. Say the roots are alpha and beta. Correct. If alpha and beta are the roots, then what can we write? A alpha square plus b alpha plus c is equals to 0, and a beta square plus b beta plus c is equals to 0. Okay, now if I multiply this equation with alpha raised to the power n minus 2, will it be wrong? Will it be wrong? Can't I write this? Yes, obviously I can write this, right? And you can also write this. And similarly, you can multiply this quadratic equation as well with beta raised to the power n minus 2. Correct? Now once you multiply this, what you are going to get? Now do this. You will get from there alpha a multiply alpha to the power n plus b alpha n minus 1, correct, plus c alpha n minus 2. Similarly here also the same will come, right? That is, let me write for you. It will be a beta raised to the power n plus b beta raised to the power n minus 1 plus c beta raised to the power n minus 2. Now if you add this to what you are going to get? You are going to get a multiply, like a will be common, right? Alpha n plus beta n plus b alpha n minus 1 plus beta n minus 1 plus c alpha n minus 2 plus beta n minus 2. Now this is your Newton's sum. This is your Newton's sum. Now you will ask me, sir, how is this useful, or how to use it? Now think about it a bit. How can we use it? I will tell you obviously. Now if you look at it closely, what you will see that how can we make use of it? See, the equation that came is okay, this, right? And now see, if can I write this as, say, k of n, like any variable that you want to use. Okay, so I used k of n. Now what k of kn is equals to alpha n plus beta n. Okay, so to denote this I have used k of n. Now similarly I can write this as k of n minus 1, correct, and that is k of n minus 2. So can I write it as a multiplied by kn plus b multiplied by kn minus 1 plus c multiplied by kn minus 2 is equals to 0. Now see how this is useful. If asked that find, like an equation was given, right? So x square plus 3x plus 2 3x 3x plus 2 is equals to 0. Now if they ask you to find alpha square plus beta square and alpha and beta, the root of this equation, how will you find this? Now this is looking easy, and it is easy because you can directly find it with the help of Vieta'S relation and the identities that I gave in the last lecture, right? But with Newton's sum also you can find it very easily. How? See, here a is 1, right? A is 1. Now what we can write this as kn plus b, that is here 3, kn minus 1. Now n here is 2, so this will be k of 1, and this will be k of n minus, like c here is 2, so this will be plus of 2 multiplied by k 0. This will, now you will find k2, that is alpha square plus beta square. Now how it is very easy, see. Now what does k1 means? K1 means that alpha raised to the power 1 plus beta raised to the power, this is just sum of the roots, that is minus 3 by 2, like minus b by a, and from here this will be minus 3. And what is k0? K0 is nothing but alpha 0 plus beta 0, so this will be 2. So how can we write this as k2 is equals to minus of 3 multiplied by k1, so our k1 also multiplied by minus 3, as k1 is minus 3, and then minus 2 multiplied by k naught, that is also 2, so this will be 9 minus 4, that is 5. Now how to check? You can also check, like you know that alpha plus beta is equals to, that is minus 3, and alpha beta is equals to 2, so use the identity and you are going to get 5, right? So this is how you can make use of this amazing Newton's sum. Now for time boundary, I am not able to do some practice questions with you guys, but I hope that today's session was amazing. We solved some AIME questions, then we solved USMO questions, and then we also learned the Vieta'S relation. I hope that you understood Vieta'S relation. Now what is your homework? Your homework is to read the Vieta'S relation from the pre-college mathematics book if you have, that is the basic that will create your base, and in the next lecture we can take up some more questions, and you can also practice the question that we discussed in this lecture. And yes, if you want to read a bit, you can go with the Pathfinder Senior, that is by, so you can also read that a bit. Don't just read the theory, don't try to go with the questions. We will do that as well when time comes, like in this lecture only the first question was from the Pathfinder Senior, that is we solved with the help of rational root theorem. Okay, so I hope that you understood today's lecture and this Newton's sum and Vieta'S relation. Thank you for watching. Bye.